Okay. Yeah, okay. So today we're going to look at these words discriminant and quadratic formula. So you'll see these appear up and we'll see what they actually mean. So what is the quadratic formula? Well, the quadratic formula is a really useful tool that we can use when we need to solve a quadratic equation that you cannot solve using the other methods that we have already looked at. And so we're going to use the quadratic formula basically to make an easier way for us to solve these types of problems. The quadratic formula is a formula for finding the solutions of a quadratic equation in the form a times x squared plus b times x plus c. So that is our quadratic formula, and we're going to use that is our quadratic equation in standard form, and we're going to use the quadratic formula to solve these equations. And so here would be our quadratic formula, the one you see here. And basically what you do to use this quadratic formula is you plug in your a, where it says A, you plug in your B where it says B, and you plug in your C where it says C. Everything else that is not A, B, or C stays the same. It's our constant, and that's why we're able to use the quadratic formula to solve our quadratic equation. So how do you use the quadratic formula? To solve a quadratic equation, you want to write the equation in standard form. So the equation needs to be in standard quadratic form. So again, that's this equation right here. Okay, then you're going to identify the A variable, the B variable, and the C variable. And once you do that, you're just plugging that directly into the quadratic equation, which once again looks like this. And then you simplify, and then you're able to solve for your x's. And that's what we were doing on Friday. We were able to solve for our different x's. And we realized that some equations have two x's, some equations only have one x's. And what we're going to look at is there's a really easy way to determine whether you only need to solve for one x, two x's, etc. So let's go ahead and look at how we go ahead and solve this. Okay, so here it tells us to approximate the zeros of this equation round to the nearest hundred. When we're approximating for those zeros, what we're looking for are those values that solve this quadratic equation, basically. And so we're going to be able to look at how to solve using the quadratic formula. So here we have an equation in standard form, right? And so that means that A would be negative 16, B would be 32, and C would be negative 10, right? And so what we're able to do is in standard form, we're able to solve for A, B, and C. And now that we have this is what we're plugging into the quadratic formula, which once again is let me see. So there's our quadratic equation. Then we're going to go ahead and substitute in our values. So I'm going to try my best to do this. I'm going to start with my A. A is negative 16, so I'm plugging in negative 16. B is 32, so I'm plugging in 32. Okay, and then C is negative 10, so I'm plugging in negative 10. And the reason this stays minus. Okay, so there I plugged everything in. I plugged in my A, my B, and my C. And so now that I have this is what I can plug into my calculator. Or what I could do is I can solve it on my own, or simplify it on my own and solve it. And so I can simplify Let's further simplify. Further simplify. And then this actually gives you two equations. And so this is what the unique thing about the quadratic formula is that it go ahead and gives you the two solutions because it gives you two equations, right? One equation, what you want to do is add negative 32 plus 19.59. And the second equation, you want to subtract negative 32 minus 19.59. So by doing that, you'll get two equations, and I'll go ahead and write them here so we can see them a little better. So the first one is plus, and that's what you're going to plug into your calculator. And the second one is to subtract it, and that's what you're going to plug into your calculator. And the reason that I add and I subtract is because of that symbol that I see right here, right? And so when I solve for that, this x will be equal to 0.39, and this x will be 1.61. Right? And so using the quadratic equation, I was able to solve for my two x's like we did on Friday. But in this instance, I'm able to use the quadratic formula to make it an easier process to solve. Okay, so does anyone have any questions here? How I got my ABC, how I got the quadratic formula, how I even got to two x's? Any questions?
Miss,
Mm-hmm.
how do you get the 0.39, the plus
The plus and
and
the minus?
negative as well?
Yeah. It's this symbol right here. So our quadratic formula contains this symbol right here. That's a plus and a minus. And so that means what you're going to do is this is actually two equations. It's one equation plus and one equation minus. And so that's what we get here. Because we have that symbol, that plus and that minus, you're going to get one equation where you add it and one equation where you subtract it. And so that's how we get two answers. We get the x when we add it, and we get the x when we subtract it because of that symbol. That symbol tells us that we need to do both of those things. It's two equations put together in one. Does that make sense?
Kinda, yes.
Yes. Okay, we'll see some more examples and you'll see what I mean by you need two equations, okay? Okay. Okay. And so basically, what does it mean for us to have these zeros? What does it mean for us to have one solution, two solutions, no solutions? Well, basically, we have all our equations in standard form, right? We have all of our equations come in this form. And depending on the relationship between those numbers, what we can identify is if we're going to get two x's as our solution, only one x is our solution, or no x's in our solution. So we might be able to solve that just by graphing that equation. Whenever we have two real solutions, what you're going to notice is that that graph will cross two places on the x-axis. Whenever we have one solution, you'll notice that that graph is only going to cross the x-axis at one point. And when we have no solutions, you'll notice that that graph will never touch that x-axis. Okay, and so basically what this tells us are these are our zeros. Wherever our graph meets our x-axis, we call them our zeros because if you think about it, it is whatever point it is at, whatever x coordinate is at, and 0. That is the coordinate of it, whatever x and 0. And so that's why we call it our zeros. So our zeros are solutions, and they're also the place at which our graph will touch the x-axis if we were to, in fact, graph that. And so a unique thing that we can actually go ahead and do, well, first, what I'm going to do is show you, okay, how do I use the quadratic formula to solve an equation that has no solutions? Well, no, once I get no x's, how will I use the quadratic equation to solve something that might not have a solution? So here we have an equation, And what the first thing you want to do here is you want to get that equation into standard form because you can't plug it into the quadratic formula unless it's in standard form. So we have this equation. I'm going to go ahead and write it again over here. And me wanting it in standard form is that I want it in the terms of this. I want it to look like this. Okay? And so the first thing I am going to do is I'm going to move this over. So that's 0 equals like this. And so basically now I'm going to combine like terms to see if I can go ahead and get it into standard form. Okay, and what I'll see is that is in standard form, right? I can also turn it around so it makes it easier to see like that. So that is in standard form. So basically what you want to do is you want to get the equation to kind of look like this. You're going to combine the like terms. The like terms here are this one and this one. You're combining those to get this value. And then you're rearranging it just so it's easier for us to look at it in terms of standard form. So now that we're here, can we identify A, B, and C? Well, yes, this would be our A, so A is 3. This would be our B, so B is -5. This would be our C, so C is 4. And so now that we have this is what we can plug into the quadratic equation. This equation right here. Okay, so I'm going to go ahead and plug that into the quadratic equation. And basically, I'm just taking my A, B, and C, the ones that I have right here, and I'm just plugging that in. So B is -5. C is 4. A is 3. And that's what I'm plugging in. We can simplify that. So we're just simplifying. What I'm doing here is I'm taking that square, distributing that gives me 25. Then I am multiplying this together, that gives me 48. So I'm just simplifying. This one becomes a +5 because you're distributing this over, making it a positive. So I'm just simplifying that. Now I'm going to simplify a little further. What am I going to do? Well, I'm going to actually do the subtraction inside of that square root. And so that gives me x is equal to so there is my simplified equation. Well, what I notice here is that I actually have a negative in here. And so because of that, I'm going to take out the imaginary. Basically what I mean by that is I'm going to do 23 times -1. -1. The negative 23 doesn't have a perfect square root, so I'm not going to mess with that. But that -1, I know that I can put my imaginary number I. So I'll take out my I. So that is my resulting equation. And what I'll notice is this actually is 2 equations. Why is that? Because you have one equation that is plus and one equation that is minus. So I can go ahead and move those over just so we can see them a little easier. I have one equation that's a plus. I'll do that in the yellow. Basically, it just contains the plus sign. And then I have one equation that is minus, and it contains that minus sign. Oh, no. But what I'll notice is that I can't simplify that any further. And so because I can't simplify that any further, um, that means that I have no real solutions, right? I'm not given an exact x value. I'm given two equations in imaginary form, but I'm not given exact roots. No real equations, so no real points at which that graph will cross the x-axis. And so if you were to plug that into the quadratic formula, what you'd end up with is you can't simplify further, so you'll end up with no real solutions. Okay, but how can I determine if my quadratic formula will even have solutions? Why am I going to mess with the quadratic equation if there's not going to be any solution? Well, there actually is a way for you to determine if your quadratic equation in standard form has solutions. And the way that we do that is we take the discriminant, which is basically this equation inside of that square root, and depending on what that inside equation equals to, that will tell us whether we're actually going to have solutions or whether we're not going to have solutions. So basically, if that inside portion, that inside equation is greater than 0, then I'm going to have two real solutions. If it is equal to 0, I will have one solution, but if it is less than 0, then I will have no solutions, zero real solutions. Okay, and so what does that mean? What does that look like? Well, say I wanted to determine how many zeros this equation would have. Is it going to have two solutions, one solution, or zero solutions? Well, basically what I'm going to do is I'm just going to first put it in standard form, then put or identify what the discriminant would be. The discriminant is just that equation on the inside of the square root. So that's the only part of the equation I'm using. And depending on what I get as a result, I'll be able to determine, do I have two solutions, one solution, or zero solutions? Okay, so first thing I need to put this in standard form. So like this is my standard form. I need to put that in standard form. And this one's pretty easy. I'll just add one over here and then do subtract 7 from there. So y is equal to my standard form. So that one was pretty easy. All I had to do was move this part of the equation over here and this part over here, put those together, and I get my equation in standard form. Now I have my a, my b, and my c. My a is 9, my b is -4, and my c is 6. Okay, same thing. Now I'm just going to go ahead and plug that into my discriminant. So -4 squared minus 4, a is 9, and c is 6. Now just simplify. -4 times -4, 16. 4 times 9 times 6, 216. Subtract this from each other. My answer is -200. That means that my answer is less than 0. What I'll see here is if my answer is less than 0, then I have 0 real solutions. So that means if I were to plug this into my quadratic formula, I would get no answer. So no solutions or 0 solutions. Okay. Any questions about this? Questions, concerns?
No, ma'am.
No? Okay. Okay. So the first thing that we looked at today is we looked at the quadratic formula. What is the quadratic formula and what does it help us solve? Well, the quadratic formula, here's the example we use. The quadratic formula helps us to solve what our zeros are. What are our x values? Where is that graph going to cross my x-axis? And so basically what I need to do whenever I'm working the quadratic formula, the first thing I want to do is get my equation in standard form. Make sure it's in standard form, because once you do that, you can identify your a, b, and c, and that's what you're plugging into your quadratic formula. Then you just simplify further down, and what you'll end up with an equation that looks like this. This equation tells you that you actually have two equations embedded in it. One that adds the top part together and one that subtracts it together. That being said, we get two solutions, one solution here and another solution here. So basically, if I were to graph that, my x would be at 0.39 and 0. So that would be 1, 0 for my equation. And the equation would also cross my x-axis at this point. Okay? So that's using the quadratic formula. The next thing that we're able to do is to use the discriminant, this equation right here, which is just the inside of that square root. And based on what our solution is of that discriminant, so first thing, make sure it's in quadratic form. Once it's in quadratic form or quadratic standard form, you can identify your A, B, and C. That's what you're plugging into your discriminant equation. And depending on what your solution is right here, depending on what that is, you'll determine whether you have no solutions, one solution, or two. If the solution that you get out is greater than 0, you have two solutions. If that equation is equal to 0, you have one. And if that equation is less than, you have 0. Okay? So basically what you're able to do here is you're able to do the same thing that we did on Friday, but in a very easier process. Basically, all you have to do is identify your ABC, plug it in. And then what you're also able to do is you're able to identify, do I even need to mess with this problem? Will I even get a solution out of it? And so that's what the discriminant does. It tells you, will you even get a solution? Will you even be able to find the x-axis of that equation? And if not, maybe you don't need to mess with it at all. But like always, we'll go over some more example problems tomorrow. But are there any questions right now? Questions, concerns? And then, like always, I'll upload a little bit of a cheat sheet so you can get a little bit of an understanding of how this can be used further. But if there's no other questions, you guys may log off, and I'll see you guys tomorrow. Bye, guys.
My miss.
Bye.